economics and environmental impact of manure and compost on various crops, including corn, soybeans, and forages. She is the editor of Publication 811, Agronomy Guide for Field Crops, and has been part of the team involved in the development of NMAN, the nutrient management software used to determine manure application and commercial fertilizer rates for Ontario crops. She lives on a farm just outside of London. So, without further ado, I will let you people take over, and I hope everybody enjoys the webinar.
Thank you, Jim. This is Jolene Rutter from Green, Manitoba. I'm just going to ask that everyone holds their questions until the end of the presentation, and then you'll be able to either ask your questions orally using, you can just put up your hand signal, or you can type in your question in the chat dialog box and I'll read it out for you. So I will let Christine start her presentation now.
Can everybody hear me all right? Well, I thank you for the opportunity to this information. This is basically the same presentation that was given a few weeks ago, and it's just a broad overview of the study and the results so far that we've got on the second out of 3 years of our study. So just to start, the whole nutrient cycle with Greenbin makes a lot of sense because we need nutrients to produce our crops. There's the food that gets produced, and when that's returned back to the land, it completes the cycle, and that's the cycle of sustainability. And we've done that with manure nutrients, but now we're looking at recycling the food waste and some of the other wastes that are not traditionally livestock and crop related. So this is a slide that's being used by various sources, but it really shows the benefits of what we're trying to do. One of our goals is to improve soil quality, and one of the things that has been disappearing since we started cultivating land is soil carbon. And so one of the things that we're doing by adding compost back to the soil or manure or any of those types of organic amendments is we're increasing the amount of carbon, and by increasing that amount of carbon, improving our soil quality. Part of that soil quality is the water and nutrient holding capacity. If we've got sites in the soil where nutrients are held, where water is held, then during those dry seasons, some of that water is available to crops that otherwise wouldn't be. And as our carbon content goes up, so does that water holding capacity. Same with productivity. It's all related, of course. If we've got good soil carbon, lower bulk densities, we've got better water infiltration, better ability for water to move through those soils, and it's all related to that chemical, microbiological, and physical balance that the soil requires. So the question that we have with compost and with organic amendments is, how long does it take for that soil carbon to increase to those ideal levels, and how much compost would it take? And I don't know if we're going to find the answer in the short term. So one of the things that we're seeing more and more often in our soils, especially as we have continuous cultivation and poor rotations that don't include a lot of cover crops or don't include a lot of organic amendments added, we get a soil that's compacted, that easily cracks in spring, and makes it difficult for plants to emerge in some conditions. Not all soils look like this, of course, but it's over-tilled, it's prone to erosion, and it's being reduced in organic matter, or organic matter levels are decreasing. So when we have a forage-based rotation, when we manage the residue, when we have regular organic matter additions, which would include manure or compost and cover crops, then we get a soil that looks more like it has improved sustainability because it's got the nutrients and it's got the microbial diversity. And it's pretty obvious which soil most people would prefer in their gardens. So our project, it's called the Evaluation of Greenbin-Derived Compost to Improve Soil Health on Cropland. It's a bit of a mouthful. But basically what we're trying to do is evaluate how green bin compost compares to some of the other organic amendments that farms are using. So we're characterizing both the nutrient and the organic matter value of that compost. We're trying to describe and figure out the logistics of getting the compost from where it's produced to the farm site in a most timely, cost-effective method where transport and application is considered. We're trying to increase the awareness of compost value to farmers and also to municipalities so that we get a balanced supply and demand. And our study is 3 years. We're just starting the third of that year. The picture that I've got here is a diagram of what our plot layout is. We try to have a fertilizer check. We try to have compost, and most of the time it's ahead of corn, so it'll be compost at approximately a 10-ton rate or whatever rate we calibrate for. And then that same compost rate with some additional nitrogen based on what that corn crop would need. And we try and replicate that either 2 or 3 times. And that's for statistical purposes. So the first year we established our sites, we did the applications for funding. We did as much monitoring, sampling, and data collection as we could before knowing if we actually had money to pay for any of it. We did a lot of testing of compost to determine a fertilizer value, to get some of the idea of what were the micronutrient and macronutrient composition, organic matter, carbon to nitrogen ratios, salts, all of those kind of things that we didn't have a good idea of ahead of time. And then we were looking at what is the best fit. Is it better to apply the compost every year, or is it better to apply it once in the rotation, looking at both the logistics and the economics. This is a picture of the harvesting of one of our sites. We use a weigh wagon so that we can measure what the yield is from each plot, and it's done in field. So what have we learned so far? We've learned that it's a high organic matter product. It has a very good balance of available nitrogen, phosphorus, and potash, and also micronutrients, specifically salt, zinc, manganese, magnesium, calcium. Those would be the main ones. There is variation in the different compost depending on what process is used, and every process has its advantages and disadvantages. The cured compost, low odor, very low risk for nitrogen loss. It's a consistency that makes it very easy for uniform application, probably very similar to layer poultry manure spreading or uniformity. It's the biggest thing we have to worry about is how strong the winds are and how does that affect the application. Ideally, we're finding that it's best applied once in the rotation. The absolute best scenario is when it can be applied after wheat harvest, ahead of the next year's corn crop, when it can be incorporated and then the nutrients are there ready for the corn crop to utilize. The other thing that we found is a big benefit. The unrestricted designation that compost has makes it much easier to access and handle than biosolids or manure, where there would be a nutrient management strategy or a nutrient management plan required, at least in Ontario. The picture you see on this slide, that is what a 10.4 ton per acre application rate looks like. That's similar to 10 tons per hectare. And the density of this material was about 31 pounds per cubic foot. Challenges with the material. Probably the biggest challenge is the transportation costs. A lot of the product has a relatively low bulk density. We've measured anywhere from 20 to 30 pounds per cubic foot, which makes transport more expensive because it is fairly light. There's been different people asking about pelleting this material to make it a little bit more dense in transporting, but so far I haven't seen any results of that. Temporary field storage is another thing that can cause some problems. When it's stored, especially in the early spring or over the winter so that it can be applied in early spring, then we see this kind of result, and that can come from some leaching of nutrients or from compaction damage. When it's stored in the field and you've got spreaders that are moving it across the field and you've got the loaders, especially when the soils are wet, that does cause some compaction damage. So ideally, this material will be stored on a cement pad near a farmstead. That would reduce the leaching. It would also reduce the compaction damage. Contaminants, plastics and glass are the issue still. There's variation from one municipality to another in how much contamination, and probably even from 1 week to another, just depending on how all the equipment is working. But some of the materials do have more plastics and glass than what we would like to see. Quite often it doesn't look like much when it's being applied, but because all the compost is utilized or is this for the cropping season, in the fall all that's left is the colorful plastic, and then the occasional popcorn and those kind of things. But the contaminants are a big issue, and hopefully as people get better understanding or better separation education, that will decrease. Timing of product availability and application can be a challenge. Timing of application is generally in the spring or in the late summer to mid-fall, which means that anything that's produced over the winter is probably not going to any farms unless it has a storage site. Consistent availability of a product is a concern that farmers have, being able to get the product, especially as demand increases, being able to get that product when they need it. Another challenge, not very often, but uncured or green compost, which means that it's stable but it hasn't cured for the 3-month period. Sometimes it's dried enough that when it re-wets there is a bit of odor, so in this case those materials are best incorporated so that they don't have an odor associated with them afterwards. And then if materials are surface applied and not incorporated, even though there's no risk for nitrogen loss in well-cured compost, there is still some risk with phosphorus loss, and with some of the algae blooms that we're seeing in the Great Lakes, that is still a concern. Ammonia is not a big issue in compost, and because the ammonia is a valuable input in manures and especially in liquid materials, it's a form of nitrogen that farmers like because it's readily available to plants. It converts to nitrate very quickly. It's also very easily lost to the atmosphere when it's not incorporated. And you'll see in this picture down here, this is where we've applied liquid manure to forage crops, and you see pails. Those pails are situated to measure how much ammonia we're losing. Underneath each of these pails is one of these dosimeter tubes. Those dosimeter tubes measure how much ammonia we're losing. The only time an issue with compost, with green bin compost, would be that stable compost that's not been cured. It still has, in some cases, a significant amount of ammonia that could be lost to the atmosphere if it's applied, let's say, in the heat of the summer or when there's warm temperatures, dry conditions, and a lot of wind. So I put this slide here just to show that methods of measuring how much ammonia we are losing, but when we've got the uncured compost that's fairly high in that ammonia, it needs a different kind of management, especially when it's fall applied to non-growing crops. So going into year 2 of the project, these were our site locations. We've got one in the Winchester area near Ottawa. The rest are in southwestern Ontario. There's not too many on the other side of Toronto just because of the time it takes to get there. So the majority of them are are in the southwestern west of Toronto area of the province. Our partners in this project, the Compost Council, they represent all the compost processors or the processors. We've got our farm cooperators, A&L Labs in London, and then the Soil and Crop Improvement Association, which is handling the project finances. So the next couple of slides are just going through some of the results from this year, again on a broad overview. This is the kind of results that we get. We look at the yield, of course. We look at test weight. We look at moisture. We look at lodging. We look at a lot of different things, and where possible, we try and get a statistical analysis to show us how much these numbers mean. Is a 10 bushel difference really significantly different, or is that just the amount of yield range that we're seeing within plots? So in this case, we've got compost from OrgaWorld in Ottawa. It has a fairly high carbon to nitrogen ratio, greater than 30:1, which means that it's tying up some of the nitrogen in our soil. And so we're finding in this plot where we're using this kind of compost, we do need to compensate some additional nitrogen to get our maximum yields. We're also comparing it here with biosolids pellets, because one of the people in the Ottawa area is working with nutrient management and with the biosolids, so they thought they would include that in the plot. So we have our just nitrogen, we have our biosolids pellets with nitrogen, we have our compost with nitrogen, two different rates, just compost, and then our check. And you can see that there's definitely a benefit to having some additional nitrogen with this compost. Probably 150 pounds is more than we need. 75 pounds it looks like that's in the ballpark. That's the kind of results we're looking at for each of the plots. We have a site at Strathroy that we're doing some detailed work on. This is using OrgaWorld material from the London area. This is the stable compost that has not been cured, so it does have some odor with it. The site that this was applied at is in the middle of a subdivision. In the background here you see a nursing home, so the property belongs to that nursing home and is rented by a local soil and crop association. So what we did at this site is we had the compost delivered in a walker type truck. It was dumped, and then we did some calibrations, but we basically applied it the same day. We calibrated our rates so that we had the rate we were wanting to apply, and then once it was applied, it was incorporated at the same time, or within the same day. We had no odor complaints. People walking by that didn't even really know what we were doing. The picture down here, it shows the plot, kind of a panoramic view. Difficult to really see a lot of difference, but this is the area of the check where there was nothing. Here is the area where compost was applied. And then the next slide shows that at the 6.5 ton per acre rate that that was one of the rates we were testing, we were basically supplying about 125 pounds of nitrogen, 129 pounds of phosphorus, and about 80 pounds of potash. So that was worth about $214 in fertilizer value. There were also the micronutrients and about 5,000 pounds of organic matter when we applied 6.5 tons. The product cost was about $5 per ton, and then the transportation and application cost, that really depends on the distance. And the increased yield potential can be significant especially when crop prices are high. So this year we had a little bit of bad luck with this plot. It was applied on April the 23rd. The site was planted on May the 3rd. It's a sandy soil. It used to be a tobacco farm probably 30 years ago or so. So we ended up having a frost in late May, and they waited because they thought that the plants were going to survive, but found out that the There wasn't enough plants surviving, so some of the plots were replanted on June the 15th. So we basically, instead of one plot, we have 2 plots. And it really does show the difference between how it would have been a good idea to replant everything as opposed to leaving one part of the plot with only half the population. But surprisingly, June 15th planted crop of corn. We ended up getting much higher yield than we anticipated. Luckily, we didn't have an early frost in September. So where we had the compost between the 6.5 ton and the 13 ton, there really wasn't a significant difference, at least not in yield from the nutrients. There was a difference where there was no compost applied, and similar, really not a lot of yield difference in the short plots, and pretty tough to say whether there was a compost benefit here because there wasn't enough population to really make it a uniform plot. Normally, May 3rd planted corn is the ideal time to plant it. On the Strathmere Lodge plot, we also did the Savita test. Savita test is it's a test that gives an indication of microbial respiration. It's a test that we heard about from Jill Clapperton from, she used to be from Alberta and now she's in, I think, Montana or one of those northern states. And she uses this all the time in her organic matter indicators. So we did this test where there was no compost applied, and then we did this test where there was the 13-ton rate. And what it showed was that where there was only commercial fertilizer, we had a relatively low soil respiration, showing that where the compost was applied, we had a much higher microbial activity. And that's what we like to see. We'll be doing more of these this year on all the plots. Another site that we did some compost application was on a low fertility forage plot. Forage is basically hay. This would be a mixture of alfalfa and grasses. The compost was applied a little bit later than I would have liked to see it planted. It was applied. It was early May, and we did some comparison with compost and then again with some biosolids pellets. These pellets are registered through CFIA, so they don't require a nutrient plan or strategy. And what we did here was we took a first cut yield, and then we also did a forage quality where we put that information into, it's called a milk program, but we basically look at, did the quality improve when we applied the compost so that it produces more milk per acre? And I don't have the rest of that part of it done, but generally what we find with manure on forages is that about a 7% increase in quality, and then we get a significant increase in yield, which makes those organic amendments a big advantage on forage crops. This was the same field in mid to late September. You'll see in this picture, this is evidence of earthworm activity. This is the earthworm manure, if you want to call it that. I've also got a picture of the soil that the forages were growing in, and you can see that that's the kind of structure we're looking for. Lots of room for water to move through, good aggregate stability. It's not going to wash away in the first rainstorm. And then in this picture, what I was really, really impressed with in the fall was how much stems we were getting from the crown. Generally in an older stand, we don't see that as much. So going into the fall with that kind of stem to crown ratio sets it up well for the winter. And then we'll evaluate this spring to see if there was any winter kill or any impact from compost versus no compost. But the soil quality portion of the project is the hardest to measure, hard to put economics on. And we realized that with the compost, it's more than just nutrients. In the States, they have an analysis that looks at the microorganisms and the microorganism balance. And we're starting to look a little bit at this part of it with A&L Labs and their biological division. But what I'd like to see is what is the ratio of bacteria compared to protozoa and compared to nematodes. Because the more diversity we have, the more benefits to the soil, both in nutrient cycling and in just crop process and crop growth. And when we're adding organic amendments, the background slide, organic amendments, sometimes we refer to it as the living, the dead, and the very dead, where the living would be the nutrient cycling that's happening with cover crops. The dead would provide the active organic matter, the food for the soil organisms. So for example, where we've got the compost, the portion of the compost that's the sugars and the phenols and the that breaks down very rapidly, it's feeding the microorganisms that are contributing to that nutrient cycling. The very dead, that's the more stable portion, the humus. It's the portion that acts like a sponge and helps to increase that water holding capacity. It's also the portion that we measure in a soil analysis when we measure organic matter. And one of the sites we have at the Outdoor Farm Show where we've been adding organic matter for the past 7 years, at that we are seeing that regular additions of organic matter do slowly increase, not huge amounts, but we're going from 2.7 to about 3.4, where we've added the highest amount of organic matter. So we are starting to see differences. It really depends on what kind of soil we're working with, though. For sands, that's a lot harder to increase the organic matter levels compared to clay soils. And it just shows you how there's different microbial populations, and each one of them is impacted by a different part of the compost. So for example, the bacteria, when a compost type material such as the uncured material that we get from Orga World or from AIM that hasn't been cured for 3 months or 6 months, the bacteria is the first to explode in population as it's breaking down the sugars and the proteins and the polyphenols, followed by the fungi that work more on the lignins and the cellulose and the hemicellulose. Then we have some of the other populations of nematodes and protozoa that come in after these populations have stabilized and have broken down some of that material. And when we get the full diversity, that's when we start getting the maximum soil benefits and the nutrient cycling and the water holding capacity. And we have a lot to learn about this portion of the soil, but slowly we are learning more as more research goes on. So here's another plot that was done near the Plattsville area. In this plot, it was done by one of the people that uses AIM or works with compost. And they did a comparison of several different composts. So the Guelph compost, the AIM compost, Peel region, a control with nothing, the AIM compost with some fertilizer and with regular fertilizer, and then just starter, and then just a control plot. And it shows that there is definite benefit from the compost. We're seeing here from anywhere from 20 if you count this plot, but anywhere from 5 to 10 bushel increase in the year of application. We're also measuring bulk density almost as a method of water holding capacity. And so just to make it a little bit easier to understand, and I don't know why these lines moved in my presentation, but they did. This one should be a bit higher. High bulk density means you've got a compacted soil. It's dense, it's tight. lower bulk density, you've got more pore space and more sponge effect. So when we've got the compost, we were looking or hoping that we would have a lower bulk density, and that's what we're seeing in these compost applications. We've done this for every plot. I don't have all the data calculated or graphed yet, but this one shows a good shows control, for example, has by far the highest bulk density, showing that it hasn't. We are seeing some benefits from that compost. And it'd be neat to be able to measure exactly how much extra water holding capacity, but last year wouldn't have been a good year for us to test that anyway, because last year was a relatively wet year. I think we would see a big difference from water holding capacity when we have, I'm not sure I'm allowed to call it drought stress, but when we water stress or plants that are looking for a drink, especially in that pollination period. Another site, and here we've looked at the yields 2 years in a row. The first year, the material was applied just ahead of a soybean crop. The year of the soybeans, we saw a little bit of response, not as much as I was hoping to see. Then the second year it was applied, there was no compost applied to the wheat crop that was grown, and surprisingly, not surprisingly, but we are seeing a significant second year response. Ideally, we apply the compost ahead of a corn crop because the corn crop makes the best use of the nitrogen. But I was impressed to see how much of that nutrient impact and organic matter impact we still saw in that wheat year. And so just to take that one step further, we applied, the compost was applied at 10 tons per acre and also at 20 tons per acre because it was in soybeans, so we weren't applying any additional nitrogen. At the 10-ton rate, we were applying approximately 90, 75, 100 pounds of available NPK, more than 4,500 pounds of organic matter, and approximately, now the soybeans weren't going to use that nitrogen, so it's probably a little bit lower than this. There was about $140 worth of NPK value. At the 20-ton rate, we don't get that same amount of value because not all of these nutrients would be needed for that crop. Material cost plus application plus transport would be about somewhere between $20 and $25 per ton. So one of the things when we're evaluating the economics of these plots, we need to look at the whole crop rotation, not just 1 year at a time, because the nutrients might be used the most by the corn crop, but we still see that organic matter benefit and some of that nutrient benefit for successive crops. And so it's really important to look at the cost of the material over that whole rotation as opposed to just in 1 year. And then the last site that I'm going to talk about is one that we did on strawberries. And the reason we did on strawberries, if we look at supply and demand long-term, looking into the future, and we look at cost of the product, it's probably going to be the horticultural operations that will be able to and probably willing to pay the most for this material. But we need to evaluate and see, does it make a difference? Do the contaminants have a negative impact or effect? And then with strawberries, we wanted to see, is there an issue with, because strawberries are probably the most sensitive crop when it comes to salt. And so we thought we would try a 2-ton and a 4-ton rate on some strawberries, day neutrals, under plastic. And so this shows the process. We had the material delivered. We calibrated it that 1 shovel full every 2 feet was going to give us the 2-ton rate, and 1 shovel full for every foot was going to give us the 4th ton. This was an experimental site, so they don't have the equipment to spread it at that rate. But if they find that this is a product that they want to use long term, then they would adapt the equipment so that it would be able to apply it instead of the shovel method. It was mixed in to the beds using this machine, then the beds, and then the plastic placed over it, and then So one of the things that we did, 4-ton rate, we applied approximately 50 pounds of salts, and we found that you really had to pay more attention to when those beds were watered. You didn't want those beds to dry out because that's when you would start to see some of this salt injury. So it wasn't a huge, it does mean that where it's used at that 4-ton rate, we do have to be a little bit more aware of watering schedules. We will be doing yields. I'm not a horticultural specialist, so I still have to figure out how to do that. But we do have some help with the strawberry specialist and with the staff that the strawberry farm has on site. This is a picture of the 2-ton, the check, the 4-ton, another check, just to show what those sites look like in the middle of June. And then that's the same plots in September. And there was a similar type of project done in Nova Scotia several years ago by Dr. Mendy Sharifi. And so we were looking at some of those results, and they were looking at a little bit different material and also a little bit different goals in the project. But we were looking at that research to say, is there other areas we need to look at? Are there other questions that we can answer in this project by looking at what's been done in some other projects? And so we try and use information that other people have generated to find additional answers, or sometimes even to say, oh, we should look at this as well. So for example, in the North study, they did some evaluation of oh, I forget what they're called, flavins, the things that are in blueberries, and anyway, they give a health benefit. So that was some of the things that we had never even considered looking at, and something that if we have money we might look at in this year's crop. The Nova Scotia study, they saw some real benefits to reducing the amount of water that was required and also the amount of fertilizer. And they looked even at the economics of their fresh weight material, and they looked at a savings of $676. I don't think we're looking at that in our project, but it is helping us to determine, okay, what kind of things are we looking at? Should we be looking at how much difference there is in water use? In our project, we're looking at additional fertilizer use in that water. Usually by the end of the season, the strawberry farm needs to use some additional phosphorus and potash. We're hoping with this material that they won't have to do that, and then we'll evaluate how much cost savings that will give. And then just to conclude with some of the press that we're getting, some of the public perception. We were really lucky to get a cover article in Biocycle magazine. It's a United States publication. They wanted to do a little bit of work on our forage plot and decided that they would do a little bit more. So it talked a little bit about our project and how we were setting up the sites and what kind of things we were looking for. There was a Better Farming issue in January of 2013 that profiled one of the farmers that was instrumental in increasing the popularity of compost, getting people curious about using it, and also providing a method of applying that material to farms. And that's one of the things that we're working on with Soil and Crop, is to try and get a online listing of people that have application equipment, because this is compost is kind of like a manure for cash crop farmers. Most cash crop farmers don't have the application equipment, so if we have a network online of where that equipment is available from, or custom applicators that can apply that material, that will make it easier for people to utilize. This is a picture of one of the crop tours. There are several summer tours that Middlesex, or not Middlesex, that any of the soil and crop improvement foundations do over the summertime. This was one site where the green bin compost was profiled. This is Travis Willing from OrgaWorld. So he talked about the process and the material and the composting process that they use. This was my summer student that did a lot of the legwork, Kalita Kono, who gave the presentation and did a lot of the data from last summer. So there's a lot of people involved in this and a lot of people that are interested in hearing the results. We had a really good coverage from that meeting in the local newspaper, Today's Farmer, where we had 2 different articles talking about that stop on the tour. And that's resulted, that media coverage has resulted in a lot of interest, numerous farm media coverages, so Ontario Farmer, Today's Farmer, Better Farming. It's resulted in a lot of farm cooperators that are looking to apply additional green bin compost, and people looking for it, and people looking at their neighbors to see, okay, is this something I want to do or get involved in? So just to summarize, our project goals are basically, this is maybe bigger term or bigger goals, to divert organic matter from landfill sites. It's really sad for us to see that organic matter is going to landfill when it really should be going back to agricultural land, especially when your soil organic matter levels are decreasing, although slowly, and it is impacting the soils in more erosion and in reduced yields. The other goal, evaluate the value of the compost compared to the fertilizer. Evaluate if compost is an economic alternative to some of the traditional types of manure that are available to cash crop farmers. Livestock manure is getting tougher and tougher for cash crop farmers to get, mostly because the livestock farmers see the value and they've got increased land bases that they can apply that manure to. We want to evaluate with the municipalities the advantage of diverting SSO as green bin compost to agriculture, showing them that this is a valuable resource for agriculture, and establishing the logistics so that from production to field we can get a relatively economical product that is of value to both the farmers, but also worthwhile for municipalities to contribute to. The findings so far, again, this is big scale, but if I look at the amount of green bin waste that's diverted from land here, and this is numbers I got from the Compost Council of Canada, it's basically equivalent to the manure volume from about 26,500 dairy cows, or basically it's equivalent to about 10% of the cow population in Ontario. Contributes over 55,000 tons of organic matter and over $5.25 million in crop available nutrients, fertilizer equivalent per year. That's the consistent nitrogen and potash. The logistics from production to field, product cost is approximately $5 to $7 per ton. At least that's the latest numbers I have. Transportation is by far the biggest expense, varies with distance. But if you look at just the bulk density of material, one load that can fit into a dump truck, a one-axle dump truck, is about 13.8 tons of gravel versus 4.5 tons of compost per load. So it takes a lot more to get a volume of compost to the location. Application cost, if you're hiring a custom manure spreader or manure applicator, depending on volume, it will be between $3 and $5 per ton. Increased yield potential, yes, we are seeing increased yield potentials, especially when we're evaluating that over a complete crop cycle or over a complete rotation. We see higher yield differences on a than we do on a wet year, or when moisture is ideal. We do see in dry years difference in drought stress on the crops. The crops look healthier for a longer period of time, depending on how long that drought stress continues. And the maximum economic benefit comes from one application of approximately 10 tons per acre ahead of the corn crop. So that's a broad overview of our project and of some of the findings so far. I don't have the full, all the results summarized yet. There'll be a full report after the 3rd year, and hopefully we'll be able to go back to some of the sites and look at organic matter over the longer term, because really organic matter takes more than a 3-year project to really be able to show a difference. So with that, I'll open up to questions.
Excellent. Thank you very much, Christine, for that presentation. Lots of good research going on, especially the long-term research. It's fantastic to see and fantastic that it's working out for you. So if anyone wants to either put up their hand to ask a question or type them in. I see I have one already here from Ronald Rusnell from the city of Saskatoon. He is asking, was the cost of the compost subsidized for the project?
Was the cost of the compost subsidized from the project? Yes, the way that our project works is that our project had over 3 years $40,000 funding, and a lot of the costs are. Oh, I'm getting to that. So a lot of the project is based on in-kind, and so the Compost Council of Canada, and that's an umbrella for the municipalities that are participating, they provided the compost to us at no cost. But in doing the economic evaluation, we do have to consider what that cost would be. So I don't know if that totally answers your question, but because this project is a cooperative effort, we do get some in-kind funding from the different organizations.
Okay. Yeah, we are getting a little bit of feedback there, so we'll try to bear with us here. The next question is from Keith Osborne, and he's from Ontario, and he's asking, how much did the organic matter increase on average? How much did the soil organic matter increase, I assume?
That's a really hard question. Yeah, and that's a really hard question to answer because the stable organic matter takes a long time to build. If you returned, and I'm just going to put this into perspective, if you returned all the crop residue that's produced by a crop, so all the wheat straw, all the corn residue, all the soybean residue, it would take about 100 years to increase the organic matter by 1%. And that depends on the soil, it depends on a lot of things. But so in a soil test, we're measuring stable organic. But when we're adding compost, we're adding, I forget what I had in that one slide. So we were adding about 5,000 pounds of organic matter. 5,000 pounds, that's 2.5 tons of organic matter. 20% of that would be in the stable format, and then the rest is helping to feed the microorganisms in the soil. So at that rate, in a sandy soil, it might take 10 years to increase the organic matter by 0.2, 0.3, 0.4, depending on what other management practices. It will go up fastest when we apply organic amendments like compost and we have a good crop rotation that would include cover crops. Because when we've got the combination of those practices, it's almost like 1 + 1 = 3. We're getting that diversity into a deeper zone and in increasing that organic matter and that activity a lot more quickly. So I didn't answer the question very well because it's not one that's easily answered. but it takes a long time to increase organic matter.
I think that was a very good answer to that question. Another one from Roland Russell from Saskatchewan. He's saying that very little corn is grown in Saskatchewan, so in a crop cycle of legumes and cereals, which would be the best to apply?
Cereals have the higher need for nitrogen. And I'm not that familiar with Saskatchewan, so I'm assuming it's a spring cereal. If it's a spring cereal, then fall application of this material means that you've got some time for the microorganisms to work on that organic nitrogen, and then you've got the best availability for that cereal crop in the spring. The other crop that in the West that would benefit the nitrogen in compost would be canola. And again, I don't know if it's spring canola that gets planted or winter canola, but it's a fairly high nitrogen need crop as well. Legumes, because they produce their own nitrogen, there will be a response similar to what you see in soybeans, but you're not getting as economic a use of that nitrogen as you would with the cereal crops.
Okay, next question from Gary in Ontario. He's asking, this compost you used was green bin compost. Have you done any tests with leaf and yard compost? And were there any differences?
The Orga World from Ottawa, the material that we had at Winchester was mostly a leaf and yard compost. It had the higher carbon to nitrogen ratio where we did have to add some additional nitrogen. We are going to be doing a plot at, well, assuming we get permission, we will be doing a plot at Strathroy Lodge this year comparing Orga World to Try Recycling, which is mostly a leaf and yard waste compost. And the thing that we would like to compare with those two is because the Orga World is the stable but uncured compost, the Try Recycling is more stable, it's been cured for a longer period of time. Are we going to see a difference in microbial diversity from those two products, and how will that affect the yield or the economic yield especially? So really interested in looking at that as we're starting to understand a little bit more about the microbial balances in the products.
Excellent. Next question. We have about 3 more questions here, so I'm going to cut the questions off after I ask these 3. First, Kurt Doward from Manitoba Conservation is asking, do you think that the increased yield benefits will offset the cost of transportation and application? So just looking at those 2 factors alone.
I hope so. My goal with compost is that the nutrient and the product, but it really has to be over the whole rotation, and I think that's why a once-in-rotation application is more economical.
Christine?
Yep.
We weren't
yes.
able to hear that answer. Can you re-answer that question?
So I'm hoping our goal with this project, if it was a totally ideal world, the nutrient benefit, so the commercial fertilizer that you don't have to buy, and the yield increase over that whole rotation is going to pay for the product cost, the application, and the transport. That's the goal. If it costs the farmer more than that, we're going to have a harder time selling it. And it really depends on what the crop value is. If we're looking at a crop like wheat or corn or soybeans, they're not as high a value crop as let's say some of the horticultural crops. So in those cases, the horticultural crops would probably benefit economically more than field crops. But right now, we still have to prove it for horticultural crops.
Hello, Jolene, are you there? Christine, can you hear me now?
Yeah, I can hear you.
Okay, just wondering if, Jolene, can you hear us?
I was wondering what happened.
Yeah, she may have been cut off, I'm not sure. Just bear with us for a second. It looks like maybe we lost the audio from Jolene. I'm not sure. Maybe what we'll do is, I guess we could end it there. If that's okay, Christine.
That's fine.
Okay. All right, then I'd like to thank everybody for attending today. This was a really great webinar. It was very informative. If you have any additional questions, you can, is it okay for people to contact you, Christine?
Yep, that would be fine.
Okay, maybe you can tell them your email address and we could go from there.
My email address is oh shoot.
Oh, I'm sorry. I don't think we heard that. Do you mind repeating it?
No, it's all right. There.
Ah, there it is. Perfect. Okay. Great. Again, I'd like to thank everybody for attending, and we will see you next month. Thank you.
Thank you.